Alright, hello everyone. Welcome back to another video. In today's video, we're actually going to be looking at a new topic once again, and we're going to be looking at computer science, Cambridge International Education Spec for Igcse, and specifically, we're going to be looking at data transmission and data packets. So, first of all, what we need to know is that data packets just carry a bunch of information. Okay, so you have this and you want to send this to a specific location, right? But you don't want to send it as a whole. So what data packets do is they split this up, and one data packet will take one, another data packet will take another will take another will take another will take another will take another. That's how data packets work. So essentially, a data packet contains three different things. A data packet will contain a header, the payload, and the trailer. Now the header will hold the source address, the source IP address. It will hold the packet number, it will also hold the destination IP address, and these are three of the main things that it will hold. Furthermore, the payload, on the other hand, will hold the actual data, while the trailer, it's not really useful, but it will hold things like, sometimes in some cases, security information, and the notification of the end of packet. So these are our three components of a packet. Now, how is a packet exactly sent? So what we need to know is a packet. So we have a set of data. Okay, the data is then broken down into packets. Okay, these packets are then assigned a destination IP address, source IP address, and a packet number. Okay, the packet will also it will hold these three main things. Furthermore, it will also hold an error detector, an error detection method, like a parity bit, and lastly, okay, that should be it. So after all these have been assigned, the packets are then actually sent, okay, via the internet and via routers. Now, routers play a crucial role in how IP addresses work, because they act sort of in weird way. Um, Essentially, what happens is, um, assume all these dots are routers, and the X's represent the source IP address, and this one is the source IP address, and this one is the this one is the, what is it called, the destination. Okay, the destination, and this is the source. I'll just label S and destination D. Alright, so these are the different routes that can be taken. This to this, this to this, this to this, that to that, that to this, this 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 to this. Sort of like a pattern, right? And these join here, here. This can also come here. So what happens is that based on the amount of traffic that there is present, internet traffic that is present, the routers will send the packets on a route with the least amount of traffic. So essentially, if the packet is here, it will eventually start going here. Okay, it will reach here, but there's traffic on this route, so the packet can either be sent here or here. But since the packet has to reach over here, the router will decide that this packet needs to go to here in order for it to reach maximum amount of, in the lowest amount of time to reach there. And imagine there's traffic here, so it's gonna move here. Then there's traffic here, 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 so then the packet has to move here. Then if there's traffic here, 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 no other option but to move here, and so it will move up then. It's a simple understanding, but essentially the router sends the packets on the router. It's actually called routing, so the router routes the packets on the routes of shortest distance, keeping in mind internet traffic. After this stage, the packet actually reaches the destination IP address. So what happens then is they come in different orders. The packets come in different orders because there's multiple of them. At the start, we said that they're assigned different packet numbers. Okay. Based on this, they don't come in that order. They come in a random order, but they are then reassembled into that order by the receiving computer. So if they come in the order of 5, 3, 1, 2, and 4, then the receiving computer will reassemble them into the correct order of 1, 2, 3, 4, and 5. It's as simple as that. Moving on, the computer will then, the receiving computer will wait for all packets to be received, then will it proceed to reassemble the packets in order. If a packet is not received, the receiving computer can request the packet to be resent, and then will it continue once again. Building on this, so this topic is essentially known as packet switching, and it helps to maintain corruption, and to keep emails safe, or data safe. Yeah, that should be it for packet switching, packets, and transmission. Next, I'm also going to talk about this right now. I'm going to talk about the different data transmission methods, the serial and parallel. So serial sends data through one line, one after the other, whereas parallel sends each bit as a part of its own line. Okay, so this would represent serial and this would represent parallel. They both have their advantages and disadvantages. For example, serial, it's it's slower in comparison to parallel, but it is cheaper, and it's good for long distances. Parallel, it's serial, it's less prone to interference. I'm going to talk about more about that in a second. Parallel is much faster, short distances only. It's more expensive though, and it is more prone to interference. Now, interference, when I mean interference, I mean that because all of these travel in the same line, they reach their destinations at different amounts of time. You see, this bit is further ahead than this bit, and this bit is further behind than this bit. This means that they reach at different times. This is what we call a skew. Skew is a very key word in Cambridge, and it's very important to use during this topic. And because of the skewing, it leads to data arriving at different amounts of times. That could lead to interference. Furthermore, because they're on the same line, the bits can get corrupted because of the electrostatic force, but we don't need to go into much detail. That causes more interference because there's more lines. Furthermore, talking about this topic, we have the simplex, half duplex, and the full duplex. Very, very easy topic, this one. Simplex data just travels in one direction. Half duplex is where they can travel in both directions. It's just that the data is only able to, give me a second. Right, so the data is only able to travel one at a time, so it can travel both directions, but it can only go from either example left to right, where all the data is traveled only left to right, and then once all that has been transferred, then it will travel right to left, which is representing half duplex, one at a time, but in both directions. And full duplex needs two different lines, where one line travels one direction, the other line travels other direction. It can be simultaneous, and yeah, there are advantages and disadvantages of simplex, duplex, and half full duplex and half duplex. Simplex is cheap, but it's only one way and it cannot support two-way. Half duplex is cheaper than full duplex, but it can only transport data one at a time, so it makes it slower. Full duplex is much more expensive because it requires two lines and it supports simultaneous data transmission, but it is more expensive. And you can also combine serial and simplex, serial and half duplex, and serial full duplex, parallel simplex, parallel half duplex, parallel full duplex. Um, Serial simplex is where data is transmitted one bit at a time in one direction only. Serial half duplex is where data is transmitted one bit at a time, but it can flow in both directions, but not at the same time because it's typically one shared wire. Um, Serial full duplex is data transmitted one bit at a time in both directions simultaneously, requiring two wires. Parallel simplex is multiple bits transmitted simultaneously in one direction only. Parallel half duplex, multiple wires and multiple bits in both directions, but only one direction at a time. And parallel full duplex is multiple wires send multiple bits in both directions simultaneously. And that's all you really need to know for this topic. These are the main key points. Thank you for watching.